Assalamualaikum and good day. Today kita akan belajar chapter terakhir, our last chapter, which is chapter 6, Statically Indeterminate Structure. Beams that have more than one span and that are continuous throughout their length are known as continuous beam. Okay, as what you see in the diagram here, this is the example of continuous beam because of it have more than one span, two span and more lah, plus. They are commonly encountered in aircraft, bridges, buildings, pipelines and various other kind of specialized structures. Continuous beams are statically indeterminate. As what you have learned in part 1, you learn about statically determinate, which means only one span beam. So ini boleh didetermine secara static, maksud dia. Static tu apa? Yang you kira reaction tu lah, you dapatkan Ra, Rb. So that is statically determinate. But if let's say macam continuous beam ni, this is what we call statically indeterminate. You cannot find the reaction just using the way macam you dapatkan masa you kira for one span beam. You have to use additional method ataupun additional calculation, so that baru you akan dapat correct reaction. That's why nama dia statically indeterminate. Statically indeterminate ni not only for beams, they're also what we call as portal frame. Portal frame not include in your syllabus This one kalau ada, this is what we call as portal frame. So dia punya connection like this, perhaps like this. But in your syllabus you only learn about statically indeterminate for beams. Method to analyze indeterminate structure, we have force method, slope deflection, moment distribution and three moment equation. So we have like 4 methods. For this, for your syllabus, what we learn is we're going to do the moment distribution method to find the reaction. This method was developed by Professor Hardy Cross in 1932. This method solved for the joint moment in continuous beams and rigid frame by successive approximation. The principles is, first there is sign convention. What you must remember and you must stick to it. Clockwise moment X on member is positive, while counterclockwise moment act on member we consider it as negative, like what you have learned masa you buat reaction like that, because kita ada like making like assumption whatever clockwise kita akan anggap dia positive, and counterclockwise for moment we going to consider as negative. We have K. So K ni adalah stiffness factor. K equal to 4EI over L when far n is fixed, and K equal to 3EI, this is I, over L when far n is rolled or pin supported. For example here, okay, you have beam like this, roller, fixed, and this is statically indeterminate beam because it have more than one span, so 2 span. For this beam, AB beam, this one, because far end meaning the outside support is fixed support. Okay, far end is fixed, therefore this beam, the stiffness factor is 4EI over L. While for beam BC, the far end is a roller, because the one yang far end tu yang dekat luar, the one yang outside so that is roller support. Okay, tengok this one so this one yang A ke B you tengok dekat A, and B ke C you tengok dekat C, dekat luar far end. Jadi this is roller, therefore for this one the stiffness factor is 3EI over L, because it says here 3EI over L when far end roller or pin support. This one is roller support. Another thing, the principles is fixed end moment FEM, means this one depends on the moment acting on top of the beam, berapa banyak being transferred to the beam. If it's point load, the way kita akan kira, kita akan pakai formula PAB square over L square. What does it mean? You have this kind of beam. For beam AB, okay, like we have, right, this is P. So P is the load, and then A is this length, okay, this is A, and this one adalah B. So squarekan dia and divide by L square, which means the length of the beam is L lah. Okay, divide by total length for beam AB itself. And if let's say UDL, for example, I draw here for beam BC, WL square over 12, which means that the L should be the length of the beam itself, and W is here lah, berapa kilonewton per meter, the value of UDL. You masukkan dalam this formula, then you will get what is the fixed end moment. We look at the example number 1. Determine the reaction on each support and draw bending moment and shear force diagram, which means that you have to calculate up until reaction and draw the SFT and BMD. We need to find the stiffness of the beam using what the principles that we have learned in previous slide. Look at again our diagram here, okay, the beam. You have one, the far end here is fixed end, and the one here is far end here, A, B and C. Far end is pin support. Maybe we can draw, so it much easier for us untuk kira, sebab kita boleh refer pada gambar ni. So this is beam A ke B, B ke C. Okay, A ke B, okay, kita kena tengok K A ke B and B ke A, sebab this method involve moment distribution, meaning that every direction kita kena kira. So we have like A ke B, B ke A, B ke C, C ke B. So kita ada 4 yang kita kena tengok dia punya based on the direction because of ada moment. KAB equal to KBA. Okay, ini sama because of far end dia for beam AB, BA ni adalah fixed support. So when fixed, you know that it should be according to the stiffness factor 4EI over L. That's why you wrote here 4EI over L. Dividekan je since you know that the length is 10 meter. Bahagikan je 4EI bahagi dengan L. E dengan I ni you don't have to concern because later on kita akan cancelkan dia when we calculate for the step number 2 distribution factor, dia akan kena cancel . And for beam B ke C, the stiffness factor should be 3EI over L because the far end here is pin support ataupun roller far end yang berada kat luar. The stiffness factor is 3EI over L. The diagram here, so ini 10 meter dan ini pun 10 meter sama. That's why 3EI over L you divide by the length 10 meter. Bahagikan je lah. Okay, you akan dapat 0.3EI for this one. We're going to calculate the distribution factor because nama dia pun moment distribution method. So you need to distribute moment. Jadi kita kena ada factor untuk dekat setiap direction of moment tu. A ke B, B ke A, B ke C, C ke B. Distribution factor A ke B. So A nak ke B. Okay, you look at here. Kita akan ambil, because kita nak kira A ke B, so stiffness A ke B, okay, dividekan dengan total stiffness dekat support A. You kena refer dekat support. Kalau you tengok DF distribution factor A ke B, maksudnya stiffness factor dekat A ke B lah. Dividekan dengan total stiffness dekat support A. Okay. So dekat support A, as you can see, you hanya ada satu, which is KAB lah. Okay. KBA tak berada dekat support A ni. However, ada plus with infinity. Okay. Why infinity? So in structure, what does it mean bila you nampak ada fixed support? Okay, it's like there is another beam that the length is infinity. Memang kalau the beam yang you tengah calculate tu memang fixed end, okay, jadi kena letak this infinity. So bila you bahagikan, when there is infinity, automatic jawapan akan jadi kosong, because whatever that we divide ke, we times ke, we tambah tolak ke, ada infinity, automatic akan jadi kosong. We calculate for distribution factor for beam B ke A. Okay. Moment kita nak transfer ke A, so kita nak cari factor dia. Because kita tengah kira B ke A, so KBA lah stiffness BA. Apa yang ada dekat B ini? Okay, kita tengok dekat support point B tu. Tengok support here. This support, we have two beams yang on that support, which is beam BA dan beam BC. That's why KBA and KBC here. Ada dua beam that stay on this support, which is beam B ke A dan beam B ke C. Okay, beam B ke A dan beam B ke C. You solvekan this one. You campur je bawah ni dulu. So, you akan dapat 0.4 EI divide by 0.7 EI. Dan jawapan dia akan jadi 0.571. So ini maksud saya kenapa EI ni we don't really have to include. Sebenarnya tak perlu nak kita kira masa kita kira stiffness ni. Kita tak payah kisah sangat. We don't have to concern, because here kita akan cancelkan dia. And for the distribution factor B ke C. Okay, so KBC lah, because the stiffness should be which beam that we talking about divide by, okay, so whatever refer to the one huruf yang dekat depan maksudnya BC, DFBC. So kita kena tengok dekat support B lah. So support B, bawah support B ni ada beam BA dan beam BC. So sama juga lagi, dividekan dengan stiffness BA and stiffness BC. Therefore 0.3 EI divide by 0.7 EI. And kita cancel, dan I get 0.429. For beam C ke B. Okay, so C ke B, so stiffness should be CB jugalah. Divide with, look at beam this one lah, because of, if you look at here, this one CB, look at whatever the alphabet here. Therefore, tengok dekat support C. Dekat support C hanya ada satu saja beam on this support, which is beam CB. Sebab dekat hujung ni dah tak ada lagi, there is no beam here, tak ada. Hanya ada beam CB saja. That's why dividekan dengan CB sahaja. You divide, you akan dapat 1. For distribution factor, the end support is fixed. You memang akan dapat distribution factor dia kosong. And if end support dia pin or roller, you akan dapat distribution factor dia 1. So the one yang dekat tengah ni, B ke A ni, if you plus these two value together, you akan dapat equal to 1. If dapat the value is different, jawapan salah lah. Jadi tengok BA dengan BC, value dia kalau you campurkan mesti sama dengan 1. Then we look at the fixed end moment. Fixed end moment always depends on the formula. Because of this formula, we look at how actually the load on the top of the beam. For beam AB and beam BA, sebab kita kena buat semua direction, so A ke B, B ke A. So AB and BA, you have 1 UDL here, which is 5 kilonewton per meter. Bila UDL, this is the formula that we need to use, which is WL square over 12. Kita akan assume dulu the direction of the moment because nama dia pun fixed end moment. So ini sebenarnya moment yang kita nak distribute kan. For A ke B, kita akan assume dia counterclockwise. B ke A clockwise. B ke C counterclockwise. And C ke B clockwise. Kalau A ke B tadi kita dah assume dia counterclockwise. That's why I put here negative. Because kita dah tahu when counterclockwise kita akan pakai negative. Using the formula of WL square over 12. So W ni adalah the UDL which is 5 kilonewton per meter. Length of the beam A ke B 10 meter. Power of 2 divided by 12. That you calculate the value here. For beam B ke A, it is UDL, the same UDL, but there is no negative. Because based on our assumption, B ke A, it is clockwise. Dia positive. When it is positive, don't put negative. Just use the same formula, WL square over 12. You will get 41.667. For beam BC, this is point load. When it is point load, we're going to use formula PAB square over L square. And based on the assumption that we made earlier, B ke C, it is counterclockwise. When it is counterclockwise, it is negative. Negative P is the value of the point load 20 kilonewton times with A. The value of A is actually this one. This is A and this is B for beam B ke C. So the value of A is 5 meter and the value of B is 5 meter. So just put A is 5 meter and B 5 meter, power of 2. And divide with the total length of beam B ke C, which is 10 meter. You will get negative 25. And for beam C ke B, dia adalah clockwise. This is clockwise. So when it is clockwise, positive. No negative here. Positive. 20 kilonewton the value of P. However, for beam CB, A and B dia lain A and B dia tak sama dengan beam B ke C ni actually. For C ke B, the value of A is here. And B is here. Okay. So for C ke B, A walaupun dia A dia lain, B dia lain. Tapi because of 5 meter, so that's why masih lagi 5 meter. Kalau length dia ni dah jadi lain, contohnya ini 4, ini 1 meter, jawapan dia takkan sama If B ke C, A is here and B is here. If C ke B, A is here and B is here. Dia ada way around Mana yang you jumpa dulu? Kalau C ke B, tengok dari C, so ini yang the first yang you nampak adalah this one. And this one is the letter B So 5 meter and 5 meter. Tapi dia positive, so it is 25 kilonewton meter. Okay, that is for fixed end moment. We're going to look at, this is the distribution table. The distribution table ni lah yang kita akan buat the moment distribution. Lukislah beam here. Make sure that you tak tinggal dia punya support ni sebab kita nak refer to support ni untuk tahu macam mana nak distribute the moment. Tulis join, so we have join A, B and C, and the member we have A ke B, B ke A, B ke C and C ke B. Masukkan the distribution factor value as what you have done previously, this one. So 0, 0.571, 0.429 and 1. This is the one, masukkan. And then fix end moment, masukkan ikut the one that you buat inside this slide FEM, this value according to the member AB, BA, BC and CB. Kita akan start to distribute. Okay, DIST ni is distribution and CO is carryover. Kita distribute dulu. For FEM, negative 41.667. So you ambil this value to get the distribution. So FEM times DF darab negatif. Negative 41.667 darab kosong and then darabkan dengan negatif. So bila dah darab kosong memang tetap kosong walaupun darab negatif. For the one yang in the middle here, what you need is you kena campurkan dulu FEM ni. 16.667 kalau you add these two together, baru you darabkan dengan, sebab I tengah buat BA dulu. So 16.667 darab dengan 0.571 dan darab dengan negatif. That's why dapat negative 9.517. For BC, member BC, 16.667 ni darab dengan 0.429 darab dengan negatif 7.15. And for CB 25 darab dengan 1 dan darab dengan negatif. That's why it become negative 25. Done with distribution. Next we do the carry over. For carry over, you just ambil je value of distribution, kita kena carry dia to another support. When you have this kind of beam dekat atas ni, any moment yang dekat dari luar, you boleh bawa ke dalam, tak ada masalah. You boleh distribute ke dalam. Tapi to distribute it outside, you boleh carry to fixed end. Tapi for pin or roller support, tak boleh carry over. So anything you boleh carry inside, no problem. Apa-apa je dekat, because dalam ni tak ada masalah Okay, walaupun dia roller sekalipun, tapi you boleh carry dia inside. Okay, tak ada masalah. Tapi to carry outside, you kena tengok end support dia apa. Kalau end support dia fixed end, you boleh carry outside. Tapi if let's say end support dia is like here, this is pin ataupun roller, cannot carry That's why I tak buat arrow. So kita boleh carry over. You must ikut another thing that you kena ikut The distribution divide by 2. So kosong bagi 2, kosong lah. Okay. For this one, you boleh carry over. So negative 9.517 divide by 2. Then I dapat negative 4.759. This one, I tak boleh carry over. That's why dia jadi kosong. Tak boleh tak boleh carry over. So negative 7.15 ni tak adalah, tak boleh carry over. So dia hilang. Negative 25 you can carry over. So divide by 2 become negative 12.5. Kita akan repeat these steps up until kita dapat 0. Selagi tak dapat 0, tak boleh habiskan lagi. The next distribution, kita tak ambil FEM lah. Kita akan ambil value carry over ni pula. Times with DF and times negative. So negative 4.759 times 0 times negative, so it becomes 0. And this one you have to tambah dia dulu. Bila you tambah dia, tetap negatif 12.5. Kita akan kira for member BA. So negatif 12.5 times dengan 0.571 and times negative. So bila negative with negative, dia akan jadi positive 7.138. Then for BC, negative 12.5 times with 0.429 times negative, then you get positive 5.362. For CB, you still dapat 0. We can carry over, since belum kosong lagi, kita kena buat lagi. Carry over, distribution divide by 2. Okay, tengok atas dia. So distribution, kita boleh carry here. So kosong become kosong. 7.138 you boleh carry over, just divide with 2. 5.36162 you cannot carry over, so here jadi kosong. And for 0 you can carry over and become 0. Okay, so masih belum kosong. Kita buat lagi another next step sebenarnya. Kat sini I tak letak. I dah add another one, DIST. You ambil CO, so 3.569 you darab dengan kosong, which is DF. So dah jadi kosong. Then darab dengan negative is still 0. So here for BA and BC, kita buat BA macam mana pun kita kena tambahkan this value. So when we add these two together, kita akan tetap dapat kosong. So kosong darab 0.571 darab negatif kosong. And then for BC pun sama, kosong darab dengan 0.429 darab negatif, it still become 0. And for CB, 0 times 1 times negative jadi kosong juga. So bila dah dapat one whole row is 0, kita boleh stop. Final moment punya value, everything here is from FEM. I'm going to add everything together. All this you just plus, and this is the value for final moment. Do it for each column, then you akan dapat value for BA and BC akan sama, but one of it akan jadi negatif. So dia akan balance dekat tengah ni. Kalau value dua ni tak sama, ataupun kalau lain sikit is okay lah. Okay, maybe you ada round up some values up here, that's why ada like 0.02, 0.03 differences Tapi kalau besar sangat difference dia, maybe ada salah kira. And another thing yang you have to look at here, dekat fix and support for distribution table, dia akan ada value. Okay, this one, fix and support. However, when it is spin or roller support, up here, fix, dia punya end support end support is spin or roller, value of moment will become 0. Next step is we going to calculate the reaction. Then baru kita boleh draw the SFD and BMD. For reaction, first what kita nak senang kira, kita akan draw dulu beam AB So beam AB ni what you can do is you can refer to the, so ini A ke B, lukis saja dahulu. Tak payahlah lukis dia punya support ni. Just you have to like write down RA and you have RB here. Okay, Rb1 Okay, RA and Rb1, because actually for beam BC nanti akan ada Rb2 and RC here. Okay, because kita nak dapatkan berapa reaction ni semua. Lukis je 5 kN per meter, only 1 UDL and A ke B 10 meter beam length. Don't forget to put the value of moment dalam distribution table tadi yang kita dah cari. Letakkan ikut value So for A, it is negative, AB negative 42.857, and for BA 39.288. Ikut dia punya arah, because kalau you tengok dalam this one, you dah dapat this one negative. So when it is negative, jadi dia adalah counterclockwise as what yang kita assume sebelum ni. Kita assume dia macam ni, right? So when we assume it like this, so this ini jadi negative and then this one memang positive and negative, so become negative, and this one walaupun dia zero tapi kita assume dia clockwise So ikut this one, so bila dia negative, here you letakkan counterclockwise lah dekat gambar ni. Counterclockwise positive, okay. So total moment, so I take moment dekat B adalah equal to 0, meaning equilibrium. So here I have RA. So RA nak ke B 10 meter. Force darab dengan distance. Okay. And then we have the UDL. UDL going to B. Okay, so 5 kilonewton adalah per meter. So this one adalah 10 meter length of beam. That's why darab 10 sebab ini adalah UDL. And don't forget to times 5 meter sebab ini adalah force. And this one adalah distance dia. So distance must be taken from the centroid of the UDL. Half of 10 meter, so 5 meter. Don't forget the moment that you calculated earlier dalam distribution table, negative 42.857 because it is counterclockwise, and plus with 39.288 clockwise, equal to 0 because of equilibrium. Then you calculate everything, you will get the value of RA. Then we can do the force equation. So total force arah Y equal to 0. You have RA already, which is 25.357 here. Okay, minus with this one is RA. Go because this one adalah load, so it is going down. So going down minus 5 kilonewton per meter darab 10 meter sebab dia adalah UDL. Jadi kena darab dengan length, total length of load tu, sebab load tu 5 kilonewton per meter untuk 1 meter, tapi sekarang beam you panjang 10 meter, plus with force which is RB. You don't have to include this moment kat dalam force equation sebab this one adalah moment mana boleh masuk dalam force. Kira and then you akan dapat RB is 24.643. Kita akan kira for BC pula. Okay, beam this one. Look at balik gambar. Okay, you have RB2 and RC. The force and one load 20 kilonewton at the center of 10 meter beam. This one is RB1 lebih bagus kita tulis RB1. And this one is RB2. Take moment dekat C. Okay, so I take moment dekat C. Clockwise is positive. And don't forget to put also the moment dalam distribution table tadi, which is 39.288. Negative here, negative 39.288. So bila negative, when you lukis dekat dalam gambar ni mesti arah lawan jam. RB2, okay, nak ke C, okay, darab 10 meter length because of force darab dengan distance, and then 20 kilonewton point load darab dengan 5 meter nak ke C, distance dia 5 meter, right? And then you have one moment here which is counterclockwise, so negative 39.288 equal to 0, which means equilibrium. Calculate everything, then you get the value of RB2. Then we do the force equation. Total force y-axis is equal to 0. We have the value of RB2, which is 13.929. Minus with 20 kilonewton the load itself, plus dengan RC, what the force that kita nak calculate dekat sini, equal to 0. So, you akan dapat value of RC. Okay, masukkan balik apa yang dapat based on this one adalah RA, Rb1, Rb2, RC. Okay, ni adalah moment tadi yang you dapat on each support tadi. Okay, sebab C ni tak ada dia kosong, that's why I tak draw lah. Okay, don't forget to put it here sebab kita kena draw juga masa kita kira BMD. Sebab dia adalah moment, so masuk dalam BMD, Bending Moment Diagram. You have one force here going up, which is 25.357. Okay, so 25.357, you have one UDL here, which is 5 kN per meter for 10 meter length of beam. So 25.5357 minus 5 times 10. 25.357 minus 50 So minus 50 you akan dapat negative 24.643. And then you have 24.643 going up, okay, because of Rb1, so dia jadi kosong balik. And then 13.929, okay, here for Rb2. No force at all, okay, for 5 meter, but here you have 20 kilonewton. Therefore 13.929 minus 20, then you akan dapat negative 6.071. And then no force again, okay, so straight line, and there is 6.071 RC here going up, dia akan jadi kosong balik. Start dengan kosong dan mesti end with 0. That's for SFD. For BMD, you need to calculate the area of SFD so that kita boleh draw BMD. Here I dah kira berapa dia punya length, this one, because if you still remember masa part 1 you must have learned this one, that you kena kira area. So because of this is rectangle due to the UDL, and we don't know actually length this one sebab length yang atas ni positif area ni positif, area ni negatif, so kita kena kira area dia separately. How I get this value? Here I namakan dia X lah, ikut you 10 meter minus X. So if let's say X is equal to 25.357, okay, 10 minus X equal to 24.643. Okay, value ni, apa ni? X adalah 23.357. 10 minus X is 24.643, this one And then you can cross multiply 24.643 X equal to 253.57 minus 25.357 X. Kita settle this one, so this one pergi sini, so dia akan tambah so you akan dapat 50x equal to 253.57 and x is equal to 5.071. So when you dah dapat value of x, you dah boleh dapat value 10 meter minus x lah. So 10 minus 5.071, that is 4.929. Then kita boleh draw the BMD. For BMD, atas ni I cakap positif, bawah ni negatif you can do, you nak terbalikkan pun okay, boleh je. Kita kena kira area dia dulu. I dah kira area for each this one. So the first triangle, the second triangle and rectangle here. For BMD, I akan start dengan kosong. So kosong, where I get this 42.57, mana ada area lagi dekat hujung ni, dekat kiri sekali ni, kat kosong ni mana ada area lagi. Tapi kalau you nampak dekat atas ni, we have moment here, which is 42.857 counterclockwise. That's why dia pergi ke negatif, sebab dia adalah negative 42.857. Direction dia counterclockwise. Then for 29.436, this negative 42.857 plus 64.293, you will get this value. Okay, because of area dia dekat positif, dekat atas, so kita tambah. For the second area, this is 60.733. This area is dekat negative value in SFD. So when negative 29.436 minus 60.733, you will get this value, 39.297. We have 69.645. The area is at the positive area. Just plus this 39.297 and you will get 30.348. The last one is 30.355. Area dekat negative. Therefore, you just minus kan. Okay. Walaupun you tak dapat betul-betul tepat-tepat kosong sebab kita akan dapat value dia negatif 0.07 kat sini. Tak kosong. Tapi it's okay because perhaps masa ada dalam calculation kita ada round off, round up dia ataupun round it down. That's why value dia not exactly 0 here Okay, but it's okay. And at the same time also, macam mana you nak check whether apa yang you buat ni betul ke tak. You tengok dekat 39.288, this one. Okay, so 39.288 ni supposedly value dia akan sama dengan BMD here because bending moment kan. So bending moment up here 39.28 the value should be the same as the one at the diagram here. But as you can see, the difference around 0.009. But it's okay because mungkin kita ada round up, round down Kalau tak, value dia memang actually betul-betul tepat lah. That's all for SFD BMD and we are done with example number 1. Okay, so thank you so much everyone and have a nice day. Stay safe. Bye.